All right, welcome everybody. This is the EMU session at IETF 123. We still need a note taker before we can go anywhere. Doesn't have to be elaborate notes, doesn't have to be beautifully formatted, just notes in the hedge doc. There's a link in the agenda to take you right to where you would take notes. Can I get a volunteer, please? Well, it'll be a very short. Thank you, Russ. Much appreciated. All right, let's get underway. So, welcome, IETF 123, EMU Working Group, our one and only slot. As it says, this session is being recorded. All right, I would like to point out that we have a note well, and this is a reminder on the IETF policies that are in effect for participating, both in terms of intellectual property as well as code of conduct. But basically, very briefly, by participating in the IETF, you agree to follow all of our processes and policies. If you are aware of any contributions that are covered by patents or patent applications that are owned or controlled by you or your sponsor, you must disclose that fact or not participate here. As a participant in or an attendee at any IETF activity, you acknowledge that written, audio, video, and photographic records of meetings may be made public. Personal information that you provide to the IETF will be handled in accordance with the IETF privacy statement. And if you are disrespectful to other people, then somebody may contact the Ombuds team at that link. Basically, a whole bunch of links if you're actually looking at the slides, and you can go and read all of our lovely information. So note really well, this is a no harassment situation. Please try to be respectful, professional. We have people from many different backgrounds who are here. Try to work well together. All right, some meeting tips. If you are here in the room, please sign in using MeetEcho, using the on-site tool. If you didn't scan the QR code outside, signing into MeetEcho should do the equivalent and get you listed as a participant in this meeting. Do keep your audio and video off if you are not using the on-site version so we don't get any background noise. Remote participants, please make sure your audio and video are off unless you are chairing, which you're not, or presenting, which you might be. Use of a headset is strongly recommended. The usual resources for an IETF meeting. And then here's what our agenda looks like. So we've got taken care of the note taker. Thank you again, Russ. We have 3 documents that are working group documents. We will hear them in this order. And then we have 5 different documents that are either not yet working group documents or are presentations of potential interest. So we've allocated 10 minutes for every one of those. Are there any questions? Okay. All right. EAP ad hoc. Dan, are you Dan Garcia Carrillo? Okay.
Yes, can you hear me?
Yes, we can. All right, let's see if we
you.
can get your slides up. Now the fun.
Great. Is there a way for me to pass the slides, or can I just ask you please to do it?
I believe you can request access with one of the.
Okay. Request slides is the button, right? If not, if maybe it's quicker, we can just, because there are very few slides. Okay, great. So this is expected to be a very quick presentation. So it's just a recap of the last update of the EAP ad hoc draft. So basically, we are going to comment on the situation since the last IETF, how the document has advanced regarding the working group last call and all the feedback that we have received. So basically, since the last IETF, we have only performed editorial changes in the draft. So we think that we have a very stable version ongoing. The working group last call was initiated also last month, and we want to thank everyone for giving feedback on the document. We have 6 persons that commented and that expect this work to move forward, and we didn't have any objections. We received very detailed reviews from Marco Tiroca and Christian Nansu, so thank you very much. Also with positive feedbacks and mostly editorial changes. And we are in the process of addressing all these comments for the next version of the draft to be submitted. And the one issue we might say that is was needed a little bit of work or explaining. It was already dealt with, but it seems from one of the mails that we needed to specify a little bit better how we wanted to manage was the channel binding. Okay, we also got some input from Alan saying that is mostly considered not needed, but we wanted to include channel binding support in it ad hoc in case it was expected or useful in any use case. And we incorporate that in the following way. So we are defining channel binding information as an opaque blob of data with a cyber byte string inside an ad hoc EAD field. So the EAD fields in ad hoc are optional, and so would the use of channel binding. In the sense, if you don't want to use channel binding, well, you will not use these fields in the exchange. And if you want to use channel binding, then you will see these fields in there. Just a small clarification, which was the one asked in the email about how we specify these EADs items to be compliant with the RFC of the ad hoc. In this case, we will define them as critical, okay? And we are not allowing multiple occurrences of the EAD item for channel binding within one EAD field, okay? We are also saying that which data is sent to perform channel binding is up to the endpoints. So this is something that is going to be up to the implementers in this sense. And we will also clarify the errors when you are sending some information and one of the endpoint is not able to verify the information, then we will send an ad hoc error back. And basically that's it for the nuances regarding channel binding. We want also to highlight that there's regarding the interest in ad hoc that we have an open source implementation of the method that you have available in GitLab, and we also published a paper about the implementation in a journal. And we also received feedback from companies in the automotive industry which are interested in EAP ad hoc being standardized. And that would be it for me. So if you have any question, comments, please let us know.
To put you on the spot, Alan, any thoughts on the channel binding response?
Yeah, I think that's fair. I mean, provisions for channel binding are a good idea, but practically speaking, nobody uses them for anything. They were there originally as part of the Moonshot trust router stuff, and they were never used by anything else. But TEEP also has provisions for channel binding. So yeah, might as well leave them in. But I don't know when or where we would use them, and it would require additional work to make the channel bindings work.
Okay, thank you. All right, so then your chair should expect an updated draft, and
Sure.
then we'll deal with the Shepherd write-up at that point.
Perfect. Thank you very
Okay.
much.
Yep, thanks, Dan.
Bart, you're up. That's to the clicker.
Thank you. Oh. Hello, good morning, everyone. My name is Bart Brinkman. I'm co-authoring EAP PPT with, or EAP Privacy Pass Token with Paresh Sawant. This is our first call post working group adoption. So for those of you who haven't heard of EAP Privacy Pass Token yet, I'm going to do a very, very short recap. So what EPPT does, it basically looks at, it's all about privacy. So the problem here is that, with any EAP method, identity could be used by either network service providers, identity providers, to share personal information, track people's location, and monitor their activities. There's a bunch of radius attributes also that could be intentionally or unintentionally used to track people, like chargeable user identity, location information attributes, and any kind of NAS identifier. So the objectives for EAP Privacy Pass Token are to anonymize access to public and private networks, but obviously still have authenticated access, and to protect against those network service providers, those identity providers that want to track you, but also against any active or passive attacker. How do we do that? We actually don't carry identity in EAP, but we carry an attestation instead. So the credential is, in fact, identity free. And we use kind of a two-step method, a double-blind method, to ensure that the issuance of the credential and the verification are not linkable. So basically, step one, a client will request an issuer for a privacy pass token, and will do so based on an attestation, which could be, pretty much anything that that client is logged into that device and has access to certain resources. The issuer will provide such a credential to the client, and then in step two, the client can actually verify that attestation against the server, and that's where EAP PPT comes in, because that credential will be carried inside this EAP method. EAP Privacy Pass Token must run in kind of a tunneled EAP method, so the phase one of EPPT must be either TLS, FAST, TEEP, and so forth. Where are we? So our first draft came out pretty much a year ago, and we presented it to the EMU working group and the Privacy Pass working group also pretty much a year ago. We got a lot of good feedback from some of the folks in the room here. Thank you very much for that. We incorporated all of it. There's just one thing that we didn't do. I don't know if Michael is in the room. There was a request for potentially a name change because of potential trademark issues with PPT. We actually checked that, and there's no trademark. So I think we can keep the name. So the draft was adopted by the EMU working group last month. Thank you for the chairs for getting that through. And we're now in a state where we've been adopted, and we really want more feedback from you folks on the document. We're basically ready to take in feedback and kind of get the document ready for working group last call when we get there. The only kind of missing section is still, or we feel is still the IANA registrations and consideration section. So that one we still have to do. But for the rest, we'd really like to get your feedback on the document. That's it. Any questions?
I guess we should also mention that we had a charter update as well, so that all
Correct.
of that went through, and I think we're good.
Let me just ask, given that the draft has been around for a little while, are there any implementations of it
Yeah,
in its current state?
Yes, yeah, we do have, Apple and Cisco do have an implementation, yes.
As an EAP method?
Sorry?
As an EAP method?
Correct.
Okay.
How many folks in this room have taken a look at the current version of this draft, or the one just before it was adopted? Got 1, 2, 3, 4, 5. All right, that's excellent. Yeah, so it'd be great to have some discussion on the list. Try to get this document moving forward.
Thank you.
EAP, AKA FSPQC. And that's Eritrea. Yep. We'll have to.
Oh, hello. Yeah, so I think post-quantum enhancements and hybrid enhancements in EPAC are prime. And so after IETF Bangkok, both the drafts were adopted by the working group. Thanks to all for the working group adoption call. And major changes were the HPK working group that got formed at IETF 122. So the references were updated in specifically the hybrid draft based on this new draft that was created, not new draft, but a new location, draft IETF HPQ PQ, and the INA considerations and the INA registry were updated based on that. These are the major changes since the drafts got adopted after IETF 122. And yeah, just a brief overview on why we're doing this. It's necessary for the path towards post-quantum cryptography, and we'll be using, of course, for the hybrid scheme, an HPK version, which is a hybrid one, and a pure ML-Chem or a PQ-Chem version. And we're doing it as two separate drafts because, of course, I think we'll have a different code points for different drafts, as well as the entirety of IETF is, of course, moving towards doing it in a separate way, as we can see in other working groups as well. And well, the major changes is, of course, the reference updates, and I would say, oops, yeah, and the KDF FS was updated to actually align with the HPK Chem version of the draft. And other than that, well, yeah, the INA considerations were adopted, were actually aligned with the QSF and the kitchen sink, which is ML-Chem X25519 and ML-Chem P256 hybrids. So we are going to be registering these points as INA considerations. And for PQ-Chem EPAC, or the pure PQ-Chem, it would be the ML-Chem 768, and we would have obviously the code points for 512768 and 1024. And yeah, I think there has been quite a lot of changes, but we would request some reviews and suggestions, and so that we can sort of have a more cohesive version on how we want to move forward. Yeah, I think that will be all.
Okay, Yuri?
But just a quick question. Are you planning to add code points for other MLChem levels?
We already have for these three, right? Oh, you mean in the hybrid one, or? Okay.
No, as far as I'm concerned, this will be sufficient. Thank you.
Oh, okay. Thank you. So yeah, we request some discussion in the working group and in the list as well offline, so that we can sort of bring this to fruition. Yeah, I think there's one more question as well.
Heike?
Yeah, hello, this is Heikki. I sent an email to the list yesterday evening, so you may probably have not had time to see it. There's some of the things they are mostly about from the implementing of coding perspective, so I didn't go into the cryptographic things there.
Okay.
I was just thinking that did you notice that in the original EAP aka RFC it says that the EAP aka doesn't support fragmentation, and the new attributes here, they would make the EAP aka messages really long. So
Oh, yeah, I think you're talking about the old EPK prime version, right? Or the old RFC, because actually this is an enhancement of the EPK prime forward secrecy, which just recently became an RFC like a couple of months back, probably. So yeah, are you talking about that RFC or the older one?
I think these fragmentation requirements or limitations come from the original EAP aka.
Yeah, no, this is the forward secrecy one, which would have elliptic curve, and I think that's probably handled. I think if you have a look at that, you can have a look. So it's based on that newer version of the RFC. So yeah.
Okay.
Thank you.
Okay, well, we can continue on that list. And just one more request I forgot from my email. So it would be really helpful if you could make an implementation, sort of reference implementation available, for example, for WPA supplicant, because it can be used then as a server and a client. So that would help creating other implementations. If you can consider that, that would be really useful.
We can probably later look into that, but I haven't thought of that yet, to be honest. Okay, thank you.
Okay, thanks.
But I'll have a look at your comments as well in the list.
Yep.
Thank you. Okay. Okay, thank you.
Thank you, Aritra.
TEAP v2.
Yes, TEAP v2, the gift that never stops giving or killing me or something. Next slide. So, thank you. Perfect. What's wrong with TEAP v1 other than almost everything, which is why we're doing 7170 bis. The key derivation is complex. It starts off with an exporter. This does not use the same text as in the document because the document is extremely complicated, as we've seen by people trying to implement it, and everyone did something different. So I've invented stuff here, which hopefully is a little clearer. So we derive an initial key for one round, then for every round we throw a bunch of crypto stuff together to derive a key based on the MSK or the EMSK, and then somehow we pick one or the other in order to get the key for the next round. The additional complexity is depending on the inner method. It could be EAP, it could not be EAP. The MSK or EMSK might not exist. Sometimes the MSK is set to 0, but not always. And the result is that everyone did everything differently. Everyone's interoperable with Microsoft, they use the MSK and never the EMSK. So the crypto binding is tied to the authentication methods, except for basic password, and not for the other inner exchanges, so the PKCS 710 exchanges. There's a lot of uncertainty around it. And the result is TEEP is not everything we wanted it to be. It sort of works enough, but we would like it to be better, I believe. So before we rev TEEP, I think the proposal this round would be to implement it first and then write down what works, as opposed to writing things down and then many years later getting around to implement it. My proposal is, instead of having a complicated derivation, we just define a derivation based on the TLS exporter. We always use the MSK and EMSK. If the EMSK isn't available, set it to 0. If the MSK isn't available, define a pseudo MSK, which is based on the data being exchanged. And so the theory would be that this at least ties the data being exchanged to the crypto binding in a way that is not done right now. So then if this proposal looks good, the proposal would be to then write reference implementations and start testing it, rather than getting consensus and then publishing the document and then writing the code. It would be a bit more of a feedback loop of getting agreement, making sure the code works, and moving on from there. So some questions: should we use TLS exporter or PRF? I think talking to Joe, the summary was the exporter is probably better, but that's really the only crypto question I have. And the question to the larger group is there appetite to update TEEP? I mean, there's a lot of people using TEEP. There's a lot of people wanting to use TEEP. And I think in order to get the full value out of TEEP, it would be good to simplify it, clean it up before we add more functionality to it. Comments?
Dan?
Yeah, thanks. So Dan Harkins, I didn't read the draft, so pardon me if I'm saying something stupid, but from what I understand, it sounds like, you're saying that there wouldn't be an MSK or an EMSK for what you're calling a method that doesn't generate them. So you mentioned like the PKCS 10.7 exchange, right? But that's not really a method. Those are just, it's using TEEP to do something else. So since that's not really a method and it doesn't generate any crypto, why would you even bother doing any sort of binding to that stuff? I think that, if there's an inner method, then it's an EAP method, an inner EAP method, and that would generate some keying material, and that's what you want to bind. But if you're just using the TEEP as a convenient communications medium to do things like CSR attributes and CSR requests and getting a cert, it doesn't seem like you should necessarily go through the process of respinning the crypto wheel and binding stuff, right? Or
well,
why are you doing that?
So that's the question. Do you want to? The alternative to doing something like this would be to just drop crypto binding completely for inner rounds that don't do any authentication.
So I thought originally it was only for EAP methods that did authentication, right? And so that things that were just TLVs wouldn't necessarily fall under crypto binding, because there was no expectation that would result in the generation of a key material. And you have some EAP methods that don't generate any key material, like PAP and CHAP and whatnot, and that And those are kind of the ones where this would apply. And there may be some other ones that don't.
Yeah, so 7170 and 717 bis say you always send the crypto bindings, which then gets into the question of what do you do when there's no MSK or EMSK, and there's all this text in there going, oh, if you don't have those, then you set the MSK to 0, as opposed to either tying the inner data, whatever it is, to the crypto bindings, as is suggested here, or saying, hey, for inner rounds where there's no authentication and no MSK or EMSK, you just don't send channel bindings or crypto bindings. But the text says you always send crypto bindings on every round. So we have to decide whether we send it or not, and if we do send it, what its contents are. And this is just a proposal thrown into the wind. Comments? Russ, I think you're up next. No?
Russ?
Yes. Trying to remember things. If you don't write it down, it never happened. Yeah.
So with the approach you're taking, I think you're limiting the versions of TLS. Is that intended?
No, I don't think it's limiting the versions, or how does it limit?
Exporter isn't defined for all versions.
Okay.
I think it's defined in 1.2 though.
Yeah, okay, so to that point, yes, the current draft says 1.3 or later because why not? Nothing. Yuri.
First of all, let me thank the presenter and bemoan the current state of affairs. IETF used to be, you have the code first, then you document how it runs so that other could interoperate. Now it seems documents are coming forward, and then people start finding out that, well, it doesn't quite work, it's not quite implementable, and so on and so forth. Maybe we can get back to the good old days. For this particular slide, I have a question. Is it possible that both MSK and EMSK are 0? And in that case, wouldn't it be better to not do the binding at all? I find this pseudo MSK rather convoluted and personally ugly. I would set it to 0. And if both MSK and EMSK are 0.
Yeah, this is a proposal. If it's better to drop the crypto bindings, then we just drop the crypto bindings. But we need a bigger discussion around this because 7170 says it's always there.
Change the text.
Exactly. So that's why we're here.
As easy as changing the code, even easier. Don't need to debug it.
Yeah. And to your earlier point, 7170 was written 2012. And I think it was 4 years ago before anyone implemented it. So, anyways, Tira.
Yeah, no problem.
Any specific reason to use TLS exporter? I mean, TLS exporter is typically used for exporting secrets from TLS handshake so that applications can encrypt and decrypt data, right? I mean, this is just, you're deriving new keys, so which is just HMAC basically to giving the input keying material to derive new keying material. So it doesn't seem like you really need to use TLS exporter in this case.
It depends. I mean, the 7170 derives the original key or seed from the TLS exporter too. This is just, let's see what we do. If we don't use TLS exporter, we have to define something for the crypto bindings in order to tie each round to the MSK and EMSK for that round. And for me, using something like the TLS exporter would be the laziest way because it's there, it's tied to the TLS version, you don't have to define any new crypto. There's just this function
Yeah,
which does
yeah, even TLS exporter uses HKDF expand label, which is a common crypto library that many other applications use basically. So you could just use that.
We would have to define something specifically for TEEP and for the crypto binding. And
It confuses when someone says I'm using TLS exporter because it's typically used to take that. So that's the cause of the confusion. Yeah, thanks.
okay, Michael.
Michael Richardson. So I just want to partly respond to Yuri. So this is a case actually of running code that was out there, that was slightly wrong, got documented poorly. And now when we have trying to get rough consensus on fixing it, the problem is that we have to decide how to get the code that's been out there replaced. Okay, so that's why this is a complicated problem, because because we did exactly what you said. We had running code in there. So I think I'm the shepherd for this document, right? And my response to this section, which I found the first two versions to be completely unreadable, and Alan's worked really hard to kind of make it better, was, gosh, maybe it's just write down what V1 did with all its problems, burn that version number, and go on. And I've said this a couple times to the working group, and I'm not hearing any great objection, but I'm also not hearing a groundswell of, yeah, that's the only real way forward. So I'm going to repeat that suggestion, that whether we do it in one document or two, that's an administrative working group chair issue. But my take was that this is not fixable while remaining compatible with what's out there. And furthermore, that we know that there's a bunch of situations where if you pick the wrong inner method, this just doesn't work.
Yeah.
Okay, and it only is functional out there because not very many people have implemented, not many people are using it, and probably they don't have the knobs that let them shoot themselves in the foot. So again, just document this, say the consensus version is version 2, and it has TLS exporter there, and do that.
So this is why 7170biz was pulled back from the RFC editor. There was text added going, oh God, we don't even know what the heck this thing is, but here's what works. And what works is the crypto binding is done on the MSK, the EMSK is ignored. Inner methods are EAP MSChap and EAP TLS only, and probably only in a particular order, and nothing else is guaranteed to work. And so the idea then for this would be define a simpler derivation of crypto binding if and when we want to use it for inner rounds. And then once we do that, it should be a lot easier to add support for any inner method. Any more questions? I think people are done with the queue. Joe.
And so, but that's kind of the proposal you're making, right? Is to define a new version number so that we can kind of put this thing in the past and move forward. And so, yeah, great. Okay.
Yeah, I mean, there's a lot of interest in using TEEP. I think given what's in TEEP v1, as Michael said, it's unfixable. It is what it is. And if people want to actually use TEEP for any of the alleged purposes, we need to make sure we have a TEEP v2 and that it's interoperable before the documents are published.
From what I've heard, the current implementations are only interoperate with Microsoft. They do not interoperate with each other. Sorta, kinda, maybe.
So
if the moon phase is right.
And Free Radius will interoperate with almost any inner method that they support. But generally speaking, on the server side, Microsoft was the only supplicant, and so that's what people tested. And for the untested variants, the servers all did something different for crypto binding. And so, yeah, TP1 should be dead other than one or two minor variations.
I fully support this approach and think that, contrary to what Mike said, V2, which would have running interoperable code and clearer, shorter documentation, would be much better, much more preferred approach.
Yes.
Naturally.
Yeah, we're not going to touch TP1 at this point, other than the fact that it's in the RFC editor queue. I don't hate myself enough to keep working on it. It's been painful.
You can touch it in a full biochemical protective suit.
Okay. Anyone else in the queue? Elliot.
Hey, good morning, everybody. Alan, thanks for all of this. I think the draft looks pretty good, actually. I have just a couple of editorial comments, and one point where you talk about how to do the MSK for things like basic password response. I think the only the thing I would add there is make it clear that those are examples, and that others, as you add other TLVs, what should the update RFC say about it? Like, here's the data, or we should think about like new TLVs, and I know we're going to talk about that soon, so it'll be an absolute, perfect time to do all of this.
Okay. Hannes.
Dan, do you have a comment still, or? Okay, make them brief because we need to.
It'll be very brief. I think part of this might be a terminology issue. You keep on saying method. So method means like an EAP method. And if something actually runs an EAP method, that's going to generate keys. If it doesn't generate, if it's not an EAP method, we should stop calling it a method. We should come up with a different word. And that doesn't involve turning the crank.
Yeah.
Methods, turn the crank. Okay. Not a method, don't turn the crank. We just need another term.
Call it an inner round then. The text already uses rounds. Hannes.
Yeah, I was wondering whether we have some ideas on how to improve that situation that we just had with interoperability, because those are the methods that actually get used. We spend a lot of time in a group to discuss methods which don't get used, which we already know from the start that it will have a very limited deployment, but the ones which have a significant sort of impact on the industry don't get sufficient attention. So maybe we need to think about that.
Okay. Thank you.
Thank you, Alan. Next we have P. Quake. Sorry, we'll get there. Getting there.
All right. This is about post-quantum authenticated key exchange. We claim that this key exchange is minimalistic in the sense that if you want all the cryptographic properties which are formally proven for this protocol, you cannot do better than this. And if you do something computationally or communicationally better, then you will have to sacrifice one or more of the cryptographic properties that this protocol satisfies. The protocol goes back to the concept of MQV, authenticate implicitly rather than with dynamically generated digital signature, which saves in many aspects, including relieving the implementation from the need to have a signature generating code. Why it matters? Because for some algorithms, such as Falcon, validation of the implementation turns out to be pretty difficult. And that applies mostly to the signature generation. Verification appears to be fairly validatable and simple. So if your code can have only verification of the signature, it would be easier to validate and get approved. So the logic of the protocol is fairly straightforward. You perform ephemeral key encapsulation to provide secure channel. Within it, you exchange identities. We use certificates, but it doesn't have to be certs. It could be, say, references or URIs to preloaded public keys. And then for authentication part, you perform 2 static CAMs, and you combine the results of all of those into KDF. Probably HKDF would be the one used, but we leave it up to the working group to decide which KDF it should be. And lastly, the protocol performs key confirmation. All the steps and all the actions this protocol is performing are necessary for the formal proofs to hold. The original version was slightly different, but it had to be modified to satisfy the proofs. Something else I wanted to say here, but I forgot. My apologies. It's been a long flight. We did not polish the integration into EAP with the hope that if, as we hope, working group agrees to adopt this approach, we'll work together on the best way to incorporate Pickwick into EAP. Performance, it's definitely better than with post-quantum alternatives. As I understand, the slides will be accessible afterwards, so I will not dwell on it and will not take your time on this. We have original version published in 2023. We are working on publishing the formal proofs. And our hope is to get this protocol as authenticated key exchange incorporated in EAP, ad hoc, and IQ2. With this, I'll be happy to accept any question, and thank you for your attention.
Valerie?
Valery Smyslov with Plus. I just want to mention that if EMU adopts this document and if EAP method with quick is defined, then it will be possible to directly use in IPsec and IQ2 because IQ2 supports authentication via EAP methods. So besides direct integration to IQ2, if it is done, it is also be possible to use to leverage to EAP using PQAP authentication. Just to let you know.
Absolutely, thank you. The hope is that incorporating PQAP into EAP would make it accessible to all the protocols and services that use EAP. The desire to incorporate it directly into IKE is to improve performance, because if it's invoked directly, it would have a slight edge over going to it through EAP. But both would definitely work.
Have you looked at the, so as you know, we're working on EAP ad hoc. What would be the overhead of if we incorporate this into ad hoc and use that as the mechanism to get it into EAP? Is there a lot of overhead added, or like, is it extra round trips or anything, or is it just framing?
Frankly, I did not look into that. It is obvious that there will be some overhead. It would probably not be overwhelming, but why cross the street unless you have to? So basically, if we can avoid any overhead, maybe simple enough to just proceed. And then there is a question: is it better to incorporate it into EAP and use it in IKE and in ad hoc through EAP? Is it better to incorporate in ad hoc and use it in EAP through ad hoc rather directly? We would prefer to have it available in as many protocols as possible for several reasons. It's more compact, it's faster, it's minimalistic, it's formally proven, and cryptographically, it's a beautiful idea. It's nicer than perform anonymous key exchange and then over it run a digital signature to prove your identities.
Guilin. Okay, thank you. So here's Guilin from Huawei International. Thanks for the presentation. I like the protocol, especially about the provable security. So I just have one short comment. Can you go back to your slides? Maybe the third one about the protocol, last part. Previous one. Yeah, here. Okay, thank you. So I think maybe last step, you also need to add the property of authentication, because here both the long-term public key of the initiator of the response responder has been used. So actually, authentication is also expected property should be certified here.
The authentication property is definitely satisfied here as is.
Yeah.
Not to mention that it has been formally proven. You cannot arrive at the same, let's call it master shared secret, whatever. You cannot arrive at the same value unless all the decapsulations and all the transcripts match. And you cannot perform decapsulation of the long-term static cam unless you possess the private key, which is basically the implicit authentication that MQV, HMQV, and the following protocols, again, all formally proven, are based on. So just like by digitally signing something, you prove your possession of the signature private key, whose public key is bound to certificate, whose has been signed by somebody else that vouches for your identity. Likewise,
I think we're running a bit out of time, so I'd like to move on. If we could take this offline, that would be helpful.
Okay, thank you. So we are also considering to how to use this one for IKEV2 together with Valerie and Yuri. But I think maybe some message process we need to be considered, because here in the protocol and the IKEV2 may process the messages in different way, even like the digest. So here, like you use the SHA-3A4 triple times, but in IKEV2 not this way. But anyway, we can consider later.
Basically, that meant chain hashing, not unlike what a blockchain is doing.
Hi, Uri. I think you have to define this as a separate EAP method to really meet the requirements that you put forward, because otherwise you inherit a lot of overhead from other protocols, like it was discussed, EAP on top of IQV2. And also in this specific case with ad hoc, there's a lot of other stuff that has been added. The main question I had was, do you have a specific use case in mind where you need post-quantum crypto, but as well want to optimize sort of the last bits out of it?
I would say that improvements are more than just the last bits, but basically, yes. Communication constrained devices. That's the main case. And if those devices are communication constrained, but not memory constrained, then you can improve this a lot more by sending references to the keys and preloading keys for CAM such as Makelis, which using as ephemeral or dynamically exchanged would be infeasible. But with a preloaded, the decent computation time and lovely small ciphertexts would definitely be a big benefit.
Yeah. But it has to be a communication technology that also uses EAP as its network access procedure. So that limits things a little bit. For example, LoRaWAN doesn't use EAP for its network access authentication, as an example. Or YSUN. Oh, YSUN does. Sigfox, for example.
I'm thinking not as much about the network as about the physical channels that limit you, such as radio, not necessarily Wi-Fi, though that could be arguable. But
Wi-Fi has a lot of overhead, like it's a chatty protocol for other reasons, but yeah.
I'm thinking more of radio channels.
Okay. Thanks.
But if you consider servers, for a client, it may not be a big deal to spend a few minutes on something while you establish connection. For a server that needs to handle gazillions of clients, every extra byte that it has to exchange or every extra operation that it has to compute would count. So even in those cases, optimizing would be better than leaving things as they were.
That's an interesting perspective, yeah.
Okay, thank you.
My pleasure.
All right, is this the onboarding one? Michael?
Is this working today?
Hopefully.
Yes. Okay. Hi. So this document was we posted, I don't know, we did in 2020, 2023 or something like this first. And a bunch of it became the EAP ARPA document, which I think is in working group last call, if not already past that. So the basic concept is that an unconfigured device wants to be onboarded on Wi-Fi. It has no credentials. And we have this space of unauthenticated client, unauthenticated EAP TLS. And the idea is that if you came and you present and you don't present any client, any credential, that the network would say, oh, that's very nice. Nice to meet you. I'm going to put you on my quarantined captive portal network. You're going to get all the wonderful encryption capabilities of EAP TLS versus the unencrypted Starbucks H. Hilton network that you're used to. If you're a laptop, that might be it. You know, you go to the captive portal, you enter your room number, and life is good. If you're an IoT device or a phone or a corporate laptop that has not yet been personalized, then you now have a network with IP on it that is essentially as good as having a wire plugged in. And now you can run your favorite onboarding protocol that runs over IP, whether that's, you know, OPC UA, whether that's Brewski, whether that's some of the other mechanisms out there. You do that. So then you need to signal this. And so the idea is you signal this with an NAI of onboarding at tls.eap.arpa. That's a little bit changed based on the EAP ARPA document. We had something different before. And that's it, really. There isn't a lot else there. So most of the document went into the other document. And I'm a little bit unclear what the right choice is in the name, but it looks like one of those is probably the correct answer. And that's really about it. The other thought I had, part of this thing, Dan, in the room, is I think Dan has it documented well that maybe this, that the concept that you might even wind up authenticating that EAP TLS with, I think you had a mechanism to do TLS authentication with DPP, right? And so my other thought was, oh, then you could do that too. That would also mix in really well with this space. So anyway, thoughts? Anyone has read this? This, I think, was discussed in the working group 2 years ago.
Yes, but the idea is
Elliot.
Hey, Michael. If I'm understanding this correctly, essentially what you're suggesting is create a standardized way to at least let the device on so that it can take care of, it can get onto a staging network. Is that what you're saying?
Yep, that's it. And
Okay.
There's all sorts of reasons for this. It can include you are not trustworthy and have to apply patches, and the staging network could give you that. It could also mean that this is the corporate network which has not yet been blessed, and so people, maybe this is actually literally what your IT department would use to bless and onboard that network, that laptop before they give it out. So there's all sorts of things. I mean, particularly my laptop has no Ethernet built in, many wired internet, so you need to get on something, and this is just a simple and automated way of getting on a network that everyone would prefer was encrypted rather than being a, difficult to type, often changing WPA key, or never changing an insecure WPA key, or no encryption on it.
Okay, I think there are 3 problems with the approach. I don't know if problem is the right word, but first, I think this is mixing semantics between layers, like between L2 and L3, in that, for wireless, you have other information that you need, like, network, like SID or something like that. The second point that I would make is that I think we already have a mechanism to do this, at least for wired, called MAB, which MAC authenticated bypass. And for the third comment I have is, I'm not sure we should be encouraging staging networks. Staging networks themselves are painful. They're painful for the customers to manage. They have to, it impacts their L3 configurations. I'm not saying that they should never be used. Right now, they're the only things that can be used in some cases. But I think they should be avoided, and we should be so I'm a little bit nervous about the direction here.
So we made 3 points. I'll address the second one, MAC bypass. That's really not going to work in an age of randomized and changing MAC addresses. Even if they're not changing, it sounds like a complete disaster of management. I don't know how that works at any residential small organization where they don't know what a MAC address is. And I don't think it works at all. I mean, you can literally use this at Starbucks to say, I want to be on your network. I want to go through your captive portal and reveal my information to you that way. But I would prefer not to, use the network-wide password, because that's shared with everyone else. And the ability of people to defend that is difficult. So I think that's a non-starter. As to your point about staging networks or quarantine networks, what I observe is that, and the reason why I come back to this, and we discussed this, in 2018, about how adding additional SSIDs to big networks was a problem because there's a limited number and they take up broadcast time, and I understand all that. So the 2 points is that, first of all, this isn't necessarily a different SSID. It's a profile of one that's there. And as far as I can tell, pretty much every enterprise out there has some kind of a quarantine network that they put devices on when they can't establish their trustworthiness. And effectively, this is the same network. There's no difference between I'm a new employee, my laptop or my device I brought is not trustworthy because it hasn't been enrolled from my laptop went sick, and I'm now on this network where I can't do much except maybe apply updates. So I think that's a moot point. Those quarantine networks are always going to exist, and there are probably going to be more of them. So let's use them to get our job done. Go ahead.
Hi, Gaetan. So I was going to say, you commented on that too. Today, when you want to onboard a user that has no credentials onto a secure network, and I think the Wireless Broadband Alliance is doing quite a lot of work on that with open roaming and Hotspot 2.0 mechanism and so on, but you do have a separate SSID to do that. Which,
you can have a separate one or not, as you wish.
Which is generally open as well, so it's not encrypted. So of course, the purpose why they get people to onboard is to provision credentials. So it's not to get you access without being authenticated with correct credentials, but it's really to get you onto an onboarding system.
Right, that's the goal. So our onboarding systems, believe it or not, do not fit in single packet EAP. Okay, you're talking about many packets. Okay, and as we go to quantum safe algorithms, it's going to be even more packets because those packets are going to be bigger. So we're going to be slicing and dicing at above the EAP layer more and more. So the complexity and the ability to have a variety of onboarding mechanisms for different devices, including go to this web portal, type in your badge ID, blah, 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 okay, and we're going to do something for you. All of that's possible if you can get them on a secure network. You just say they have an onboarding network which is unencrypted, right? So why do we have to do that? We don't need to do that. We can give people an encrypted network, and it also updates, you know, all of the random coffee shop networks potentially. That's what they're doing, right? They have an open network. This is equally open network, except that now we're putting some good crypto on it, and you can then do step 2 if you want to do step 2. And if you don't want to do step 2, just drink your coffee. Don't do step 2.
Yeah, so I agree on that. So the value of that, it basically allows everybody to be on an encrypted layer 2 network.
Yep.
What I wanted to say is that the onboarding part, the step 2, which is what you call, would anyway be encrypted, because you would go onto a onboarding portal, which itself would be using TLS at the application layer. So that doesn't make a difference, but it brings everyone to an encrypted layer 2.
I disagree that it doesn't make a difference, okay? I think that the difference is that you have eliminated all manner of layer 2, 3 attacks, including, by the way, ARP spoofing of the default route. That is such a common thing now. There are multiple products for home users to accelerate or VPN you somewhere else that exploit the fact that our connection between layer 2 and layer 3 is brittle, right? You can do ARP spoofing. That is an exploitable product thing for a decade now, right? So it's one of the issues why we want to do at coffee shop networks. They want to do isolation between users, is to avoid that kind of thing, right? But not everyone has that well done, has it built, and this kind of also lets you manage that process. You know, it's an EAP method, so it can be backhauled and all that stuff, and it can be managed by headquarters rather than the local entity.
Okay, I think we need to,
I'm done.
Keep the discussion going. So,
is there objections to doing this? I guess is the real question. Yeah. Sorry to take your.
Yeah, I mean, I think there probably needs to be more discussion, because I'm hearing some pushback on some aspects of this, and so we'll. Yeah, quickly.
Yeah, quick comment on the objections part. I mean, this is called onboarding, but couldn't it be also just be stated as anonymous secure access?
Could be, sure.
Because that's really what it is, I think.
All right. Next, we have DHCP options. Alan?
Yeah, so this is a collaboration between Elliot and me. Proposal initially by Elliot that DHCP configures a lot of things. It seems a little weird to do all kinds of post-quantum crypto and then throw UDP packets on the wire and get a UDP packet from someone for IPs. This can also validate, another slide, here we are. Sorry, TEEP can do a lot of that too, because the central server has a lot more information about the network other than IP address assignments. You can then put your DHCP options inside of TEEP. They're now provided securely to the supplicant, and it allows you to separate a little more your network configuration from your IP address assignment. So if your device at the edge is assigning IPs, you don't need to reconfigure that to change things like printer addresses or anything else. And consolidates a lot of administrative service functions and helps with operational complexity. So we define a new inner TLV for transport of DHCP v6 options. It's just a TEEP TLV. You encode the DHCP options exactly as they are. And there's some method for merging them at the client or supplicant. We can do this for DHCP-v4 too, but we haven't done that yet. And this just seems to be the simplest way to do this kind of thing. There's provisions there for merging the results. The idea would be that if you get options over a secure channel, you should prefer those to ones that you get over an insecure channel, but hopefully that conflict does not happen. So the idea would be the insecure channel, which is DHCP-v6, has as few options as possible, and then you add ones which are sent over TEAP. So there's some thoughts on this. If we go back a few years, there's, I believe it's RC 5505 from the IAB saying mixing different layers is a horrible idea, don't do it. I think there may be some thoughts after that this perhaps is not a terrible idea and has operational value. So questions, comments. Elliot may have some additional comments, but Gaetan.
Hey, Alan and Elliot remote. Just a quick question for understanding. The DHCP is, the parameters that are passing are local. When you're doing TEAP, the authentication can get back to the home network. There's two sets of informations. There's local informations and there's global informations. How would the home network be able to pass? I mean, the home network can't pass local data information. So are you within that creating, separate layers of information that you pass where the intermediate relay, local relay would be able to also insert local information in TEAP or?
No. So the local relay wouldn't insert any information. There's two sets of local versus remote. One is where you have a DHCP-v6 relay. This would not affect that, but the other is also roaming, as in EduRoam, Open Roaming, etc. The idea for roaming is your AAA server would notice that you're not on your network and would not send these options, right? That would make sense. Yeah.
Because so you gave in the data set you were giving like printer example.
Yeah, exactly.
So yes, you could have a remote home printer or you could have a local printer that you want to use. So we would have to differentiate. It would be nice to maybe tag, in a sense, which informations are remote and local, such that the device can know that he has different sets of services as well.
And this comes into the channel bindings discussion earlier, where arguably the supplicant could put inside of TEAP its channel bindings, which is, hey, this is what my local network looks like, right? You can do a lot of that with Radius because a lot of that is public in the Radius packet, but it would also be useful for the supplicant to do that. And that way you have double checking. But yeah, this is a problem which needs to be addressed.
Okay, great.
Joe?
Yeah, I mean, I think this has, I like the idea, but I think that point that Gaetan brings up is important. Like, how do we get that kind of difference between local and remote? And in the past, we had tossed around some ideas of like, maybe we pass keys down and then DHCP could be keyed, but that has its own huge set of problems.
Yeah, I mean, that was a proposal I had a long time ago about you derive a DHCP signing key from the MSK, public MSK, EMSK that's sent to the NAS, and you can sign the DHCP packets or not, and then depending on whether or not you believe those signatures, they exist, you can add a little bit of additional security.
But I think there's stuff that you definitely got to work out, but it's something we should look at, I think.
Okay. Next.
Elliot?
Yeah, I would say that sorry if I'm loud here. normally loud in person, now it can be loud remotely. The issues that I think we have to address are, first of all, are we putting the information in the right form, right? The easiest thing to do is to just copy the binary as best we can from the way it's formatted in DHCP to into TEEP. But that leaves a couple of other problems. Problem number one is, well, you really can't do, you have to choose then between V6 and V4, or you have to find a bit to steal to indicate the difference. And the other issue is if you want to do any form of scoping in terms of, when this stuff is valid, that requires changes. Now there was a draft actually that looked at doing like a Yang model for DHCP options. And that raises the other reason to use binary, which is the moment you go into some sort of transposition of the information, you need a data model or data model representation. And it's a matter of how much work we want to put into this and what we actually need in order to start shifting things into this secure substrate.
Hannes?
Yeah. So two thoughts. On one is in DHCP, we have all sorts of different information in there. Some of it is very session specific. It needs to be refreshed and revoked and all of that, like the IP address leases. But then there's also sorts of other information, which is more global. And I think that would be really good to have, like all the configuration of SIP servers and etc., which are often tied to the specific users. So that binding would be quite natural. And obviously it's protected as well, so it would be really a good fit. The other aspect that I was wondering is, we have been discussing for a very long time this idea that wouldn't it be nice to have a sort of an interface from the end host to the network to exchange all sorts of information securely. And we had various attempts to do that, but for some reason, we never really got there. I don't want to mention any protocol names that were entertained at the time, but it's still something that is kind of missing, and DHCP is really an odd one in this whole game with the way how it works. It's a little antique, and yeah.
Yeah, we probably also need a registry. I know there's a DHCP options for DNS registry. So for this, would need a registry as to which option should exist inside this. So there's
but it's a good work. So
okay, thank you.
Yeah, good morning, everyone. I'm Thiru from Nokia. This draft is about PQC enhancements for EAP TLS and EAP GTLS. Since this is just a 0.0 version of the draft, I'll mostly focus on the problem and some of the solutions that this draft talks about at a very high level. Right. So I think many of us know that CRQCs are going to come in the near future and just going to break traditional asymmetric key algorithms, and EAP methods which use TLS are vulnerable to CRQC's attack. So if you look at TLS, there are two parts to it. One is the key exchange, right, and the other is the authentication part, which involves signatures exchange. So both of them are susceptible to attack. The first one is susceptible to harvest now decrypt later, which threatens long-term confidentiality, and the second one is can happen when you have CRQC, which plays as a man-in-the-middle attacker to spoof the identity of either the client or the server. So the first one is something that could already be happening today. Right. What's the problem with this attack? So if implementations today have already started using EAP with TLS 1.3, most of the TLS handshake, excluding the client hello, is encrypted. The client certificate cannot be pervasively monitored by anyone, but with harvest now decrypt later, the identity of the authenticated client, the client certificate could be extracted, and several of the PII information could be extracted by CRQC in the near future to know which client has authenticated at what time and several other PII data. The other problem this draft also talks about is basically the problems that are already being listed in RFC 9191, which regard to fragmentation problems and round trips causing heap sessions to be dropped, and how to deal with that. One of the solutions is being also discussed in this document. Right. So this document basically gives 3 recommendations basically on mandating hybrid or PQ for key exchange in EAP TLS and TTLS, and mandate PQ or hybrid certs for authentication, and it proposes a certificate chain optimization to avoid the fragmentation. Right. Hybrid key exchange is basically combining both the classic and PQC chems so that you derive hybrid key shared exchange. But this document also talks about various optimizations that could be done during the TLS handshake to avoid large key shares being exchanged, which would cause fragmentation. So this is how I see TLS working group has progressed in the last year, I believe, with regard to standardizing both hybrid key exchange, which is already deployed by the industry, and then PQC key exchange, but which would be probably required in cases where there is a government mandate that you have to deploy, like CNSA 2.0 says, if you are using traditional, you have to migrate to PQ. But I believe IETF and the industry has already deployed PQT hybrid key exchange, so that would be a natural transition to get defense in depth strategy. Yeah. So the other attack is basically when you have CRQCs, which could basically break the connection, which would cause credential theft, privacy, and user deception. So that requires to update the X5.net certificates to leverage PQC signature algorithms. There's still a lot of discussion happening in TLS working group. TLS working group has adapted the pure PQ, which is the MLDSA based draft, but whether to pick up composites or dual certificates is still under discussion. So I've left it open for in the future revisions to address that based on how TLS working group takes it forward. So and I plan to update the draft accordingly on that. But the transition path for hybrid is still not being decided, at least in TLS working group so far. Yeah, so the ETLS must have to adapt either pure or one of the hybrid schemes that TLS picks up, so that would address the active attack. And then this draft talks about various techniques for reducing your certain your handshake sizes, especially the certificate exchange. For instance, it talks about one mechanism where you could retrieve the intermediate certs of your EAP server, so that when the EAP TLS session is initiated, the server just provides the leaf certificate and not the intermediate certs, which basically would drastically reduce the size of the TLS handshake. Yeah, I mean, probably it's too early for working group adoption call, but I would like to have more comments and suggestions on this document.
Great, thank you. I guess, how many folks have had a chance to read this document? Okay. Probably be good to look at it some more. I think it's probably relevant to some of the other discussion we've had here, and different, probably more options will become available, but looking at what we do with TLS is probably important.
Yeah.
Yuri?
I'd like to make a couple of comments. One, authentication is not crucial as of now, because the main risk here is not the end user certificates, but CAs. Only when crypto relevant quantum computers do become available, only at that time end users would need to worry about their digital signature certificates. Regarding hybrid versus there's a pure post-quantum key encapsulation. The only case when hybrid would help is if post-quantum CAM fails and fails to classical attack. And quantum computers that are crypto-relevant do not materialize. Because if the concern is harvest now, decrypt later, then your pre-quantum pre-quantum protection such as RSA or elliptic curve will not help you. When QRQC arrives, that will fail guaranteed. So it is a protection, but the degree of security it adds is minimal, and whether it is worth the trouble of maintaining two code bases and such is questionable, which is why some governments decided to mandate hybrid and some governments decided not to.
Yeah, thanks, Yuri. I'll respond to both the comments. One is that, right, it's not just about when CRQCs arrive, right? Nobody knows when CRQCs are going to arrive, and even if they arrive, there could be a period when state players may start shipping CRQCs and the players who are going to deploy this are not even aware. And the second problem is the transition path. How long is it going to take for you to convince your CAs to basically support this, for your infrastructure to be upgraded, right? Your trusters to be upgraded. So there's a big migration path, unlike just exchanging key exchange, that you have to bring all your infrastructure up and running. For instance, in my deployments, I have to talk to my HSM vendors and make sure they get ready to this, right? And if I have standards, it helps me to talk to my CAs, HSM vendors, and everyone who's managing my PKI infrastructure to basically deal with this in a way that we start adapting this. Now, hybrid signatures is just a defense depth strategy that since there could be vulnerabilities in, let's say, implementation of MLDSA, you basically test the waters with both the ones, right? And figure out that your systems are working, and then eventually you deprecate one of them, right?
All right, I'll just note we're over time, so make it quick.
Yeah. I just want to say that I think we have to start working on this sooner rather than later, because first of all, it takes us some time. And then we also need to, like, the specifications need to get finalized, the other ones that we are dependent on, and then we need to implement them in devices. So it's a broad ecosystem. And so, and doing all the testing, interoperability testing, and so on. So that takes a long time. So better get started sooner rather than later.
Thanks, Ernest.
Go ahead.
Yeah, I think crypto, MTI and so on, I think that's best handled in the TLS working group. I don't think there's any need to do that here. I think fragmentation was a problem before PQC, so more work on how to solve that in EAP would be potentially work from the working group, yeah.
Yeah. Thanks.
And regarding multiple transitions, from observation, people tend to minimize the risk, the problems, the time that it takes for organizations and governments to actually do the transition. We seem to hand wave on that. In fact, experience from United States, a transition was mandated several years ago. Still, it is not where we want it to be. I strongly suspect other countries are in the same place. So when we say we transition to hybrid now, and then we'll transition again to pure, I tend to be skeptical. We as the world haven't made the transition successful yet, even when we are aware that harvest now, decrypt later is a real threat.
And the transition has already started happening. If you see several deployments that we're using today, browsers and content providers are already using hybrid key exchange. There are others which are not. So we want to do the best, and we can do for people who don't care about giving the best security practices. Thank you.
Thanks, Dura. Okay, that is everything. Thank you, everyone. Thanks for coming to EMU, and it's a wrap.